So first, let me add my welcome to you. Thank you all for coming. I'm Jennifer Fawcett, the president of the Georgia chapter here. Just a few kind of logistical stuff. We're getting started with the speakers' presentations. There should be note cards on the tables and pens. Those are for writing down questions. We're going to have a question and answer session at the end. So if you could just write down questions. Also, keep in mind. Ask general questions. We can't answer specific treatment questions. So if you have general questions, write them down, and we'll have question and answer session at the end. So we're going to start with Dr. Gary Cutter, who is a professor of biostatistics. I can't say that word. Thank you very much. At the University of Alabama at Birmingham. Head of the section on research methods and clinical trials, interested in design, analysis, conduct, and interpretation of clinical trials, epidemiological studies, and evaluations. Enough. Okay, Dr. Cutter.
So I'm not Henry. That's a good thing, both for you and me. And most of you have no idea what a biostatistician does. Bio means biological, statistics means statistics. So I'm interested in statistics in medicine. And my area of expertise is in clinical trials. And I got involved with Myasthenia Gravis because I actually published a paper many years ago, 1999, in the journal Brain. And I didn't think it was going to get published there. It's a very good journal. And the National Institutes of Neurological Diseases and Stroke asked me, could I help this guy get this grant funded? Well, the person who was the editor of the journal, who was also the person they were asking me to help, was John Newsom Davis. And he is probably one of the most important people in myasthenia you may or may not know about. He was doing research up until this trial, and I got to be the PI of the Myasthenia Gravis thymectomy trial, only because I knew him and only because I knew how to write a grant for our institute. He's from England, or he was from England, and he was actually killed opening a clinic in Romania in a car accident. And the study is continuing, and it's going on. And that's what Henry and I and Gil Wolfe and a few others, a surgeon by the name of Al Jaretsky, are really carrying out and going to finish this study, both in his honor and for all of you, so we can get an answer to the question of, is thymectomy worthwhile? So one of the things that happens in a trial is you have some opportunities, and one of the opportunities is biomarkers. And Henry actually gave this talk in New York and said, can you give this talk? I said, sure. So interrupt me with a question if you have one. Some of this is kind of foreign. Some of it may not even seem important. And that's what we should take your questions rather than what's on the slides. So what is a biomarker? That's what I'm going to talk about. I'm going to talk about biomarkers in myasthenia gravis and how they have melded from other places. And I think we're going to talk about the opportunity that's occurred in biomarkers that have arisen out of the thymectomy trial. So what is a biomarker? It has a definition. It's a characteristic of some sort. A lot of people think about biomarkers as genes. It's not. It can be, but it can also be a laboratory test. It can be a measure of function. And all of these can be biomarkers, and that's what we look at. Cholesterol level is a biological constituent of your blood. CD4 counts is a very special kind of biomarker in HIV infection because it's close to what we'll call a surrogate, and I'll mention that again. People talk about surrogate outcomes, outcomes that stand in the place of clinical outcomes, and such outcomes as a surrogate usually give you a signal as to what's going to happen long before waiting for the clinical outcome. And in a research environment, that's what we'd like to know. We'd like to have surrogates. Because if we had surrogates, we could do shorter studies and move the disease investigation process. We could find treatments faster. Unfortunately, we have very few surrogates in any disease. CD4 count is one that's close, and that's one of the few that we have. People use blood pressure for cardiovascular disease. So high blood pressure has been shown to be a risk of stroke and mortality. And people use that to develop drugs showing if they can reduce blood pressure, by inference they can have a benefit on the outcome of the disease. And that kind of biomarker, that kind of surrogate biomarker, enables research to go on at a faster pace and may actually be useful at a clinical level. Because if you are taking a drug and your blood pressure is not going down, someone can change drugs or add drugs to it because they can move the biomarker for you, which then in turn lowers your individual risk. So biomarkers are very important. We just don't have a lot of them. Clinical endpoints, they're important. They're ultimately what we're looking at. We're looking at, how a patient feels. We might look at survival. That's, in cancer trials, that's become a standard outcome, or disease-free survival. In diseases like multiple sclerosis, which now, in the past 15 years, have gone from essentially no drugs to having 6 licensed drugs and a couple more that are very close to being licensed, they're beginning to use an outcome measure called disease-free outcomes. That is, you have no measurable disease that you can see. That, of course, that's the goal of everybody. It would be great to be disease-free. Or at least if you have the disease, not have any symptoms or complications from it. The FDA plays a major role in this. They have a difficult job. They have to assure that a drug has efficacy, that is, it works, and that it's safe. And they're a hurdle for pharmaceutical companies and researchers all over to get through, so their definition of what an outcome is becomes very important. They generally want to see clinical outcomes. They don't like biomarkers because they distrust them, not because they're evil, but because they don't want someone to pick an outcome that just happens to work very well with their drug. You could design something that moves something, and it may not have any effect on the disease. So they are interested in clinical outcomes. When they accept a biomarker, they often have a patient-reported outcome to go along with it, to try and make sure that this treatment that they're licensing has some meaning clinically. So clinical endpoints are often very important for FDA approval. And back to our surrogate endpoints, it's intended to be a substitute for a clinical endpoint. So CD4 count, if it gets very, very low, that's just a marker of certain types of cells. When that gets very low, you have a very high risk of death if you have HIV. And that's been shown over and over again. So the therapies are evaluated on their ability to keep those levels high. And that is one of the few biomarkers that really have been useful in moving therapy forward quickly. It's a tremendously high standard. There's a mathematical definition of what it requires, and it basically translates into, if you move the biomarker, you move the treatment. And if you take into account everything that you've moved in the biomarker, there's nothing left in the clinical endpoint. It's all explained by the surrogate outcome. And that's a standard that we rarely achieve because not everybody behaves the same way. I'm sure within this room there are different doses of prednisone, there's different doses of everything. Not everybody has the same response to treatment. So achieving a surrogate becomes a very, very difficult and complicated. So there's a hierarchy, and we put surrogates up here at the top because they have such a high standard. Now, biomarkers generally fall below that, although they can be a surrogate. But we almost say, let's look for the biomarkers, and if they're a surrogate, great. We've made much more progress than we expected. But we can still use a biomarker as a very important part of trying to do our research. So in the use of these biomarkers, which are now, I said, a lower standard but still have very big value, we can evaluate animal models. Does the biomarker move in the animal? So we have a way to see whether a new drug or a new pathway or a new treatment might be potentially valuable. And we can use it to sort of say, well, you know, if it works this way in animals, maybe it'll work this way in humans. Let's try a few humans and see if we get this. You know, animals and humans, we're different. We're very, very similar to animals. We hate to admit that, but we are. And so doing things in animals give us some idea of what's going to happen in humans. If we didn't have an animal, and I have 2 new puppies, I do like animals, so I am talking about experimenting on them. Some people get offended by that, but there are things that you need where processing of the drug is very different than trying it in a laboratory dish. So they provide a safety net. Many of you in the room may remember thalidomide as a drug back when it was used as an anti-nausea drug in pregnancy. And in that situation in the US, it was tested only in 1 species of animal. And part of the problem was rabbits don't have the effects that other humans or other species. So we test drugs in 2 species to make sure that we're not going to have the same kind of birth defects that grew out of the thalidomide. It doesn't stop us from having bad effects of drugs, but we've learned in the system that we want to have safe and effective agents, and we go through steps to try and make sure that we expose humans to the least risk. So that's where animal studies come in. And they can prove the mechanism. We can do studies that find out, is this working as I expected it to work? And lastly, safety. You know, there are all kinds of safety issues that are very difficult to study. It's easy to say, you know, you take a pill, you fall over dead. That's not good for you. That's an easy one. But there are many others that look at, you know, what happens to somebody when they take a drug in terms of maybe they could become pregnant. There are drugs that have effects that affect offspring of those mothers. And that becomes something that we want to know about, and we can't wait 2 generations to see what happens to people who've been treated with a drug. So we use animal models to try and give us enough insight to make sure that it doesn't guarantee that those kinds of bad effects won't occur. But it gives us less of a risk that they'll occur than if we didn't do them. So using biomarkers, we can also evaluate the drug response. There's a concept everybody sort of thinks about, and that is more is better. And it's not true. There's a point at which more will kill you. Water is a great thing. Without it, you can't live. But you can drown by drinking too much water. Something as good as water is for us, it can still be harmful. So there's a range where more isn't better. And it's even more true with drugs. Drugs are developed under the concept of finding an LD 50, lethal dose 50, where 50% of the animals would die from the drug, or a maximum tolerated dose. Where is the dose set such that I get so many side effects that this would not be tolerable even if it worked? And that is dose response testing, and it's a very important part of drug development. And of course, as I said, safety monitoring, again, safety markers can be used. So evidence-based medicine is something that we can root in biomarkers. That's a big word now. Insurance companies love to hear it. Because why should we pay for something for which there's no evidence? And there's different levels of evidence. Randomized trials are, of course, at the highest level. And sometimes there are treatments, many of which in MG have been utilized without randomized clinical trials. And they have a weaker standard. They provide a weaker form of evidence that a treatment works. There's a very big drug that works in every disease, and it produces about a 30% response in every disease that's been tried. It's called a placebo. And I mean, there's articles from the 50s that talk about how much of a placebo effect is. Now, I'm not saying, by the way, if any of you happen to have been in a trial, taken a placebo and really felt better, I'm not saying it doesn't work. We try, the reason we use placebos is not to make you sick, but is to harness all the things that go on in the body that are a product of the treatment protocol. And some of that is psychological, some of that may be biochemical, induced by the fact that you are under therapy, and it may really produce biological effects. We're just trying to have the exact same procedures in place for one group that's treated with an active or a test drug, and the other that's getting the placebo. So if you happen to have ever been on a placebo and responded to it, there's nothing wrong with you. It's okay. It's exactly what we want. We just want to know how much of that can occur by going through the process of taking drugs and doing some things where it can be nothing more than you finally feel in control of your disease because you're doing something for it. So placebos don't mean no treatment, but they do mean presumably not as many side effects. We actually do collect side effects in placebo-controlled trials, and lo and behold, people have the same side effects to the placebos as they have to active drugs, and we look there, and there's, anyway, you got the idea. Biomarker development, again, the last bullet up there is many believe the Critical Path Institute has been pushed by an institute that's trying to look through existing trial data, and the FDA and NIH are having an initiative that we try to find better biomarkers so that we can do clinical trials cheaper, faster, and actually better, and expose fewer people to trials, not because we don't want people in trials, but because we want an answer sooner. So what's the challenge? Validating a biomarker as a surrogate is extremely difficult. It's not easy. You have many, many things you have to show. One of the things you have to do is a randomized trial, ideally, with both the biomarker and the clinical outcome in them, and show that they actually predict the clinical outcome. And you want to do it more than once, because guess what? Once isn't enough. It can happen by chance. You can watch television at 2 in the morning if you want to see, whatever somebody's advertising. It works, this has cured me. Well, reproduce that. Do it again, at least one more time. Many times we actually, depending upon the severity of the consequences of that decision, one might want to have more than one validation. And if you have a large treatment effect on a biomarker, it may not translate. It may be an accurate biomarker. It may be an adequate surrogate, but it may not have a big treatment effect. You can have a bigger treatment effect, still have a valid surrogate, but you may not have very much what we call clinical effectiveness. So again, the process is arduous. So now that I've told you how bad it is, we've had some interesting success in the world. And I picked, this is not Henry's slide, but I thought I would put it in there to sort of give you the balance of what it is. We have drugs that have been targeted to specific kinds of responses, and what we now call personalized medicine. Doesn't mean all medicine in some sense is personalized, unless you get it over the internet, I guess. And even that can be personalized. The idea is that we learn something about a subgroup of individuals, and we can treat them in a particular way that has better results than the average population. So we've had this, the HER2 biomarker is a receptor in breast cancer, and a particular drug targeted to that, and they actually have very good results for a very difficult form of breast cancer. And you can see CML, chronic myelogenous leukemia, Gleevec, this drug that has had very good work. It's also, I think, working in colon cancer. And I'm not selling drugs, by the way. Well, not those. And you can see the other ones. So we've been able, and most of these have a certain characteristic that you can see up there. And that is, they're all cancers. That doesn't mean that the cancer researchers are better. At least maybe they are, but I don't think that's the answer. It's that you can take out a tumor or cells and experiment with it. You can make cell lines and you can see what works in there. And they know that that is the cause of the disease. In MG, it's a little more difficult because what we have is a disease and we have symptoms. And you have markers of it, you might be antibody positive or not, but we don't have a tumor we can take out and say, well, I guess a thymoma, but we don't really have the same sort of systems that they work in cancer. And if you think about the number of cancer studies and trials that are going on, that the National Cancer Institute in Washington's budget is huge, like multiple billions of dollars per year. So there's a lot of people working on this. And so far, we've got 5 examples, maybe there's more. So that the success rate is actually right now quite low. But we may be on the cusp because of the technologies that we now have, that we actually can make advances. So, MG, are there opportunities? Well, we think so. Antibody receptors, most of you are familiar with, I suspect. We have it, it's easy to obtain, it's highly specific to MG, very sensitive, responds to treatment at an individual level, but it doesn't predict either clinical severity or downstream outcome. So it doesn't meet our criteria for being a surrogate or even a good biomarker. So that the issue becomes people have a reduction in their antibody levels when they feel better, whether they were treated or not. And you can't separate what's going on from one treatment to another. Single fiber EMG, everybody likes that. It's measuring something. But it does require a lot of expertise. It's not easy to generalize across clinics. So if you're having 2 different people doing it in different clinics, it may not have the same precision of measurement, and it makes it very difficult. So it is responsive to treatment, but it could be not specific enough. So that's not what we're going to see as a surrogate marker, at least with today's technology, and it's not even a good biomarker by today's technology. So in the Myasthenia Gravis trial, the thymectomy trial I briefly mentioned, we're actually collecting a variety of samples and storing them. We started the study without enough wisdom to know what to do with them. So we said, why don't we get them and store them? So we have material from blood called the Buffy coat where you can get DNA. We have the thymic samples for the half of the patients who have had a thymectomy. We actually take some of the thymectomy and preserve it so that people can do studies on this later on after we know the results of the trial and see what is actually occurring. And there may be samples in there that people can do other things that we haven't even thought about yet. We have RNA, plasma, serum, and you can see when they're collected over the course. So we have when people come in and what happens with them over time. We've got a little over 5,300 samples broken out this way. It's actually higher now from when the slide was made. And this is a resource that we're putting together that we hope to mine and try to understand what happens. We'll know what happened to patients over 3 to 7 years when the trial's over, and I must say that we will recruit our last patient this month. So finally, recruitment will be closed, which has been a long time in coming, at least for me. And we will celebrate when we close recruitment, and we will wait until the last patient completes 3 years of follow-up, and then we will, in essence, present the results. of the trial. This data will become available, the baseline data will be available now. Once we close recruitment, we can let researchers access this data for ideas they have about what might be associated, and one can use data from this registry and these biomarkers that might come out of here to compare to other populations, either other diseased populations. I have a similar set of measurements, for example, on multiple sclerosis patients, and we have normal controls for them. So we can look at whether or not there's differences that we can see between normals or other diseases and markers that might be present in these samples. So we have a few already that we've already identified that we have at 6 months. Our samples in the Myasthenia Gravis trial come from all over the world. We have 60-something sites, and many of the patients are actually from outside the U.S. So what we plan to do is do a broadly based biomarker discovery on a subset of samples. We're not saving one sample, and once we use it, we're done. We have multiple what we call aliquots of these samples. So we're going to look at the integrity of these samples and do a broad spectrum profile of these from the baseline to make sure that we can actually learn something. That the samples are good, that there's a chance that we might see something that looks different in myasthenia than we see elsewhere. Those are some of the tests, and I'm not going to go in there. We're going to look at this with regard to disease severity when people came in, progression, responsiveness to treatment, whether or not certain patterns of biomarkers predict who's going to respond to steroids or who has adverse reactions to them. And we're going to correlate those biomarkers to what's actually occurring on the thymus. I was recently with Angela Vincent, who's a very well-known, I guess, to all of you, researcher in myasthenia, and wants to test the idea that you can tell by looking at the thymus whether someone's been exposed to prednisone or not. And we have about 30% of our population that came in prednisone naive, and 70% had already experienced prednisone. And we can test that hypothesis about whether or not there are permanent changes that are appearing in the thymus from the prednisone. You can say, we're going to do other kinds of molecular stuff I don't need to go into. And hopefully we can validate some of these biomarkers that they actually have value that may give us clues to how someone should be treated, as opposed to a clinical paradigm that is really what we call a trial of n equal 1, which is, each of you is an experiment. When you respond, one's happy. When you're not responsive, one does something else. And if we had biomarkers that, like the HER2 breast cancer example, that we knew this specific treatment was going to work in this specific biomarker positive individual, we would have a better job and we could shorten your experience with treatment. So I think there's a real value in doing this. And the team is the same group that you're listening to us, and Henry, and we're going to move forward, and that's really the ultimate goal, is to make things better for patients. It's not about us having sort of an intellectual exercise about trying to figure something out. That's important, but it doesn't even matter if we don't really understand how it works. If it works, that's good enough, as long as it's safe. So thank you. And now back to Paris. And I will point out, for those of you who have ever been to Paris, it's rare to see a blue sky behind the Eiffel Tower. It's even more rare to see the moon. Questions? Comments?
I have a question. How do these particular drugs get their names? Like Celebrex?
They actually hire companies to come up with those. But there is a certain pattern to them. There's a lot of drugs now coming out that says MAB, natalizumab, et cetera. It stands for monoclonal antibody. So there is a rubric behind them, but some of these drugs have names that...
How did Mestinon get its name? for instance?
That's an older drug, so that must have really been thought about in a different way. I mean, I'm certainly that there was some. You sure it wasn't Mastodon?
No, I'm not that old.
No, not you, me. I don't know. I don't know how it got its name. The names are bizarre in many cases, and you got me stumped. I mean, I know that they hire companies to come up with these, and they're paid a lot of money to do it, and they come out making no sense to me. They usually convey something about the disease, you know, and what they're trying to convey something about, you know, how the drug's going to work, and there's a positive spin that's supposed to come out of it. But when I hear some of these names, I'm just.
I was looking at your list, and it's like, who can pronounce those things, and what are they for, and how did they get named?
Well, Herceptin, working on the HER2 receptor. You know, I mean, there's a linkage there in almost all these in one way or another, but sometimes they get morphed based upon what they're supposed to do. Don't ask me Viagra. I mean, the underlying drug is sildenafil. Well, the funny thing is the drug was actually a lung drug. You know, sometimes side effects can be a good thing. Rogaine, I should have changed the example quickly. But Rogaine was originally a blood pressure drug, and it had this funny side effect of producing hair. And, you know, sildenafil was a lung drug. We're actually doing a trial with neonates with the drug, trying to improve primary pulmonary hypertension. And, you know, when I can't pronounce sildenafil, I just say, yeah, it's a Viagra drug in little kids. And they look at me like, what are those little kids doing?
One of the biomarkers you had up there was RNA. Is that in any way related to DNA? And my second question is, can it be scanned and figure out DNA if somebody's predisposed to maybe getting myasthenia gravis?
You know, there've been family studies done. You know, family study is an old-fashioned biomarker for genetic risk, and that works. DNA and RNA are closely tied. RNA is involved in replicating of the cell and transfers the information. It's not the same as DNA. It has to be captured in a different way. And both are valuable because one tells you about, you know, what's going to happen. The other tells you sort of what's permanent. The problem with the old way of doing it, which is the family way, you know, we teach kids that, you know, well, you have DNA and it describes certain characteristics of you, and that's what you had. And when I was taught that, I was told I had black hair. And, you know, certain things change. Certain characteristics with DNA, of course, don't. And it's very useful for some things, but there's also changes that do occur, and where in the process do things go wrong. So DNA, RNA, we talk about proteomics, the proteins that are there. We're trying to figure out what happens to them and how do they work. And the body is incredibly complicated. It has one wonderful characteristic, and it's also the worst characteristic from a research point of view, and that is there are multiple pathways. It has redundancy built in. So if you take one thing out, something else can take over the function. And when that happens, when you're looking at these biomarkers, you might see something, but what you may be seeing is the reaction of the body to the disease that's taken over a function that was messed up before.
But it's not perfect redundancy, and that's kind of the issue.
Exactly. No, that's why it makes this. If this were just simply Mendel's peas, you know, which one is yellow, which one is green, and you had good graduate students, you'd be done. And we're done with those simple problems.
How do you get chosen?
Well, there is a website called clinicaltrials.gov, and this website was mandated partly for this reason. You know, I use it not because I'm volunteering for studies very often, but rather I can see what studies are being done in a particular area, and you can too. When you go onto this website, it basically, you can put in, you know, what disease are you looking for? And you can see what trials are active. And this involves both pharmaceutical company trials as well as university-based researchers or anybody who is doing a trial who ultimately wants to publish the results from their trial must register before the trial starts with this website. And that's a very useful way. In terms of other sources, I'm sure that there are local resources. You can probably, there's a website called Something Share, I'm blanking on the first name of it, which is the idea to put patients in touch with studies that need them. Recruitment is one of the most difficult parts of almost every trial that's being done today. Part of that reason is, I suspect, that we've made research somewhat of a dirty word. We picked on the bad examples and we've made it difficult to recruit. The other part of not recruit, because studies require a lot of effort on the part of patients. They're not given enough credit. You know, I'll get up when the myasthenia trial's over and I'll present the results and someone will think I did something, but I didn't do anything. It's the patients who've had, we have not had dropouts in our study, hardly at all. And the ones that drop out usually have a very good reason for it, like death. You have to admire why someone would continue to provide the information, which is altruism. We all are trying to do things to make other people better. And that is a gift. It's a gift to the research community, but it's also a gift back to patients. It's just a long time till you get that return. So, if personally, you can always call somebody and they can try to help you find the right study for you. There may not be one. Myasthenia is a little bit underrepresented in clinical trials in the U.S. And it's because it's a rare disease and trials cost enormous sums of money. They're depressingly expensive. Some of which is all the things that have to be done under FDA regulations, and some of it is just the inherent cost of the infrastructure to follow people for a long period of time. Yes?
Would your talk be available on a flash, be available to take with us after this meeting, or?
Yeah, we're recording. Hi. So we're going to make them available later on, yes.
So yes.
Okay.
What was the criteria for selecting the subjects for this particular example?
They were immune to the immunomodulator, the monoclonal antibodies. They couldn't be exposed to these very complex drugs because they have characteristics that do alter the immune system that we didn't want to bring into this question. And so they were newly diagnosed. They could have some short exposure to various drugs. They could be on prednisone. They had to have antibody positivity of greater than 2, and we had an age limitation that after we got started and found how hard it was to recruit active patients, we've screened over 6,000 patients and we randomized 124. We have 123, I believe. I think it's about the same number refused. When faced with the ultimate idea that somebody like me could flip a coin and say what their treatment was going to be, thymectomy or not, they looked at me and said, that doesn't seem like a good deal. And we expected, we actually planned for 50% of the individuals to sort of back out when it really came time to having a random number. But it was a very, there were a few other criteria that they're actually on the website under clinicaltrials.gov. But it's a relatively small, they could not have a thymoma.
You answered my question.
Okay.
I have one more question. You talked about the availability of the data. When will that be available for mining and to what researchers?
It will be available ultimately publicly. One of the nice things about doing an NIH study, it's also one of the nasty things when you're doing it, is that at the end we have an obligation to make the data public. So you as the public, in essence, have paid for it, paid a lot of money for it, and you should have an opportunity to have it. So you will. We have a requirement to make it public within a year after we publish the primary paper. So that is probably about 4.5 years away, which is sort of, but if you have a specific question, certainly within our baseline data, I can answer that. I don't know it off the top of my head because we haven't completed recruitment yet, so we've restricted ourselves from playing in the data, as you say. And we won't. You got me to shut up?
No, whatever you do that, yes.
I'm done. You can, if you have a question, you can call me, but the data will ultimately be made public.
So our next speaker is Dr. Charlene Hafer-Macko. She's an associate professor of neurology at the University of Maryland in Baltimore. She's the director of the MG Center there and the Baltimore VA Medical Center Neuromuscular Clinic. Right now she's doing research on exercise in myasthenia. And so that's what she's going to talk about is kind of where she is with her exercise study. So, Hafer-Macko.
Thank you for the opportunity to come. And you can hear me in the back okay? Good. Just as a survey, how many of you exercise now with your myasthenia? Actually, that's a nice handful. How many of you been told not to exercise with your myasthenia? Now, there's a few of you that have been told that. And most of the time, at this point, is if the myasthenia is active and you're still trying to get under control for the myasthenia, we limit it. But back probably about 20 years ago, I think, how many of you were told I don't know if any of you had myasthenia 20 years ago. How many were told originally not to exercise? Well, when I was training, we said not to exercise because it's a disease of fatigue. And so it's going to make MG worse. But there's a lot of health reasons to really think about exercise. What were you trained? Were you trained? Did you ever hear anything about it?
They just said to count. I'm a statistician.
So he counts.
What did he say?
He said count. I said, were you told not to? He said count. And exercise can be counting too. So in thinking about myasthenia gravis, this disease has changed over the past century. And I don't have a pointer, but I'll see if I can pull the arrow. So the prevalence of myasthenia is about 2 in 10,000. And originally, back at the turn of the century, have the arrow. Okay. So, but now I've got to do the mic and this. So at the turn of the century, I am going to do the arrow. I think that'd be. I'll just kind of take my hand down. So you can see the writing is small, but in the 1910s, we started with tracheostomy and intubation. Ventilation came about in the 1920s. Some of the antibiotics came out in the 1930s. And prednisone came out in the 1970s, if you look at the 60s. So a lot of the things that we're using now really have come out maybe in the past 20 years. Plasmapheresis was in the mid-70s. IVIG was about 85. So the therapies that we have for myasthenia have changed, which means survival has changed. And the course of myasthenia has changed. So now people are living a long life with myasthenia. And how many of you are on prednisone or have been on prednisone? And what does prednisone do? The uniform response was this, not words. So waking, it affects bone health. It affects your cardiovascular risk factors. And so if you've got blood pressure, diabetes, you want to keep active, but you're not given recommendations. So how do we do this? So there are many things that affect health with myasthenia gravis, and most of the work has really been focused on the top left-hand corner, looking at the dysfunction at the neuromuscular junction and looking at the biomarkers, the antibodies that we have to diagnose the disease. But there are so many other things happening with myasthenia gravis, and I don't think it's really gotten the full attention. So Steroids are my favorite things to pick on. So not only does it cause weight gain, it increases the risk of cardiovascular risk factors, it causes osteoporosis, interferes with sleep, causes insomnia, makes it hard to stay asleep, but it also can affect muscle performance. And then, because it's a disease of fatigue, it also causes sedentary lifestyle. We have the obesity, it affects lung function, and as we start to age with this, then we compound it with cardiopulmonary changes, sleep disturbances, and guess what happens with age? Has anyone heard of the term sarcopenia? It's a muscle wasting. So as, it's like when we're young, we can build muscles. It doesn't quite happen as we get older. And then you couple that with deconditioning. And what happens is we're first diagnosed with myasthenia gravis. You have trouble chewing. So you restrict the calories that you get in. You also limit what? You can't chew, so you get rid of a lot of the protein. And your body knows where to take protein. The muscles is a good source. So it accelerates this process. So many people lose weight at the beginning of the myasthenia, and it's that good weight they're losing, and they put on a different kind of weight. So this is what happens with aging. You can see on the right side, that's what we look like when we're nice and young. We have a lot of muscle mass. But as we age, we start taking the habitus on the left. And this is just normal aging. This is not steroids. This is not myasthenia gravis. We start losing muscle mass. So we lose about 30% of our muscle mass from 20 to 80. And what do we replace it with? Fat. Yep. That's what happens. So there are many things that happen as we age. So as we age, we actually, our own natural steroids will change. Growth hormone, which is a factor that we produce, actually helps maintain muscle growth. It actually starts decreasing as we age. Thyroid dysfunction can affect the way the muscle works. And then insulin resistance, which is that pre-diabetes. These things all happen with age and are an effect of the muscle loss. There are changes with our hormones. So as men age, the testosterone levels drop, and that has a negative impact on muscle. We also, mitochondria are your fuel cells. How many of you heard of like antioxidant vitamins we're all supposed to be taking? Well, those are things that are working at the mitochondria to try to keep their health. As we get older, we start having disuse. We're not quite as active, even without the myasthenia. In studies of people going to space, which is the ultimate loss of activity, they go into zero G, it accelerates their muscle growth. What happens as we get older? We also start taking in less food. So you get nutritional changes. So these are things that happen with age, even without myasthenia. So no one has really explored this with myasthenia gravis. So the question that we came up with at our center was, myasthenia gravis and many of the medical comorbidities can promote a sedentary lifestyle. These can lead to body composition changes. This is looking at muscle and fat mass, which then may compound the functional difficulties and impair cardiopulmonary health and metabolic health, so looking at diabetes and bone health. So specifically, I wanted to know, having myasthenia, does this impair physical functional performance? Does it affect physical activity, the daily activity of the day? Does it affect muscle mass and fat mass? Does it affect fitness? And I'm going to define this. And does it affect ventilation? So I'm part of a geriatrics group in Baltimore, both at the VA and the University of Maryland. So we've been looking at healthy aging. So we look at individuals from the community without medical problems. But many of them are not active. So this is our healthy population. And then I have a few people that have entered the study thus far. And so we looked at their differences. So they're in their 60s, about 60, equal males and females. In terms of MG symptoms, this is a symptom scale. It's an 8-point scale. I don't know if any of you took this in the clinic where you're asked about double vision, you're asked about troubles chewing, arm weakness, leg weakness, shortness of breath. So the folks who came into the study had mild symptoms. It's 0 to 24. Also, there's a quantitative MG test. And vital capacity for the individuals with myasthenia were about 2.5. Have you guys had your vital capacity measured in the clinic at all? So a few of you have. So for women, it should be about 3 liters. For men, it should be about 4 liters, but it's really based on your age, your height, your weight. So that's just a general rule. So looking at walking speed, the individuals who were from the community were walking at their fastest comfortable speed, about 4 miles per hour. With myasthenia, it was about 2.5 miles per hour. And this is walking over a 30-foot distance. So this is what it takes to walk room to room. We also looked at how much distance can people cover in 6 minutes. So we set up cones in our center, and we look at how far people were walking. And so with our healthy group, they covered almost 2,000 feet. With myasthenia, with this slower walking speed, they covered about 3/4 the distance that the other individuals were covering. We looked at getting out of the chair. It's called a test called Get Up and Go. So walking is one thing, but it takes a while to get up out of the chair, to get up, steady yourself. So it almost takes 1.5 times what it does for the other individuals to get up out of a chair. Then we asked them just to go up and down out of the chair for 5 times. And again, it was almost 1.5 times. So everything is much more effort with the myasthenia. The other thing we did was we put step monitors. How many of you have worn step monitors? The little pedometers? So I saw 2 or 3. How far do you go in a day? How many steps do you take?
About 15 to 2,000.
What's that, 15 to 2,000? And how much do you take? When you, yeah.
I actually do about 12,000.
Okay. Now, and 10 is the number that, how many have heard of like Healthy People 2010? So Tommy Thompson made a recommendation. For health and wellness, we should be walking about 10,000 steps a day. And so it's one of the things that we're very interested with our exercise center is how do we keep people active and give them targets they can accomplish. Now, did you start at 12,000 steps? No.
No, it was more like 3.
Okay.
Some days it was 3 and then,
But you got to start somewhere. And so, 12,000 is a lot of steps each day. So our healthy community individuals who were in their 60s took about 7,000 steps a day. So they're still below that 10,000 recommendation for Healthy People 2010, and we have new revisions for 2020. My individuals with MG, even though their symptoms were very mild, were taking the same as what you were taking, about 15 to 2,000 steps a day. So the other thing we do is we put, they're called ActiCals, so they don't just capture the steps, they capture their little gyroscope you wear on your waist, so they capture getting up, getting down, laying down. And ideally, we like to see the bars up here, and we'd like to see the little blue ticks in a much higher range. So their activity levels were low, as well as the number of steps taken each day. So our next question was, does this affect body composition? So one of the things we do is, it's called a DEXA scan. Now many of you have had DEXAs because we use that to look at bone density, but we can also use it to look at fat mass and muscle mass. And so usually we're not collecting that data as a clinician. So how many of you had DEXA scans? So not as many. given how many people were on steroids, it's one of the things. You had a bone density. A bone density is a DEXA scan, so more of you have had it, and it's a pretty simple test. You lay on a table, and it only takes a couple seconds. So, and it doesn't. The radiation dose is very low. So one of the things that we do is we look at body mass index. And so many of the cardiologists and your internal medicine docs want you in that normal range. They don't want you too low, but they also want you in the normal range, which is we want to keep you less than 25 for your body mass index. So have any of you done a body mass index? It's much easier in the metric system, which we don't use. But we have the equation, and there's many online. You can put your weight in and your height, and your age, and figure out your body mass index. So many of the individuals coming into my study are not in the normal range because many of them were on steroids. So many of them were overweight or met into the obese category. Now this is based on height and weight. What we found was a little more disturbing is when we use this DEXA scan to look at the lean muscle mass and the fat mass. This is what they would be predicted to have their percentage fat based on body mass index. But as you can see, these individuals who are normal or just overweight actually have a much higher percentage of fat, and therefore they also have less lean muscle mass. Now, as you're trying to walk and you're trying to get up out of a chair, how much does that fat mass help you? No. And what we're finding is the adiposity. Fat is not just a storage depot. It actually has a number of substances that it can secrete that are not healthy, and they can worsen diabetes. So we wanted to look at it more in a rigorous way. So we actually did CAT scans of the leg, and we did them of the hip, of the waist, right at the top of the hip. So you can't see the subcutaneous tissue, but you can see this muscle. This is what a normal 25-year-old looks like in their mid-thigh. This is what happens when we're 81. So you lose about 30%. Yeah, I saw some eyes go, wow. So we lose about 30% of our muscle mass over the years. Now this doesn't show up very well, but this is the 60-year-old, one of the females, which has a significant amount of adiposity. And then we have the male. So even though they look sort of normal size, when you look at the amount of muscle mass, there's a lot of sarcopenia or loss of muscle mass. The other thing that we look at in terms of diabetes risk is something called visceral adiposity, or that central adiposity, when you get the fat that deposits centrally. That's an increased risk of diabetes. We see a lot of visceral adiposity. So, changing subject, one of the things we do in our lab is look at cardiovascular fitness. Have any of you heard of sort of fitness testing? Well, Lance Armstrong is probably the ultimate in fitness. His fitness levels are about 90. The people who are in their 60s are about 25 to 30. We've got some of the young folks maybe in their 40s. I don't think they're going to make it up to Lance's kind of fitness levels. So what fitness measures is how much oxygen you use to move at your maximum capacity. And it depends on a number of things. So oxygenation starts in the lungs. So it's your pulmonary capacity. Then you've got to deliver that oxygen to tissues. So that's your cardiac output. So how well the heart is working. The next thing is you've got to deliver that blood. So it's how well the vasculature can deliver the blood to the tissues, and where you're going to use the most oxygen is at the level of the muscle. There, if you have more muscle mass, you're going to be able to use more oxygen as you're moving. You've got to have capillaries to deliver the blood, And then we talked about that mitochondria. They're the fuel cells. They're the ones that use the oxygen. And then you have to have enzymes to be able to use the oxygen you deliver. So what happens with age? So normally, our fitness will drop over age. It's disappointing, I'm sorry to be the bearer of this news. But in our 20s, our fitness levels are in the 40s for men, a little lower for women, and we just have a steady decline with age. So the individuals who come into the study are lower than their age predicted. This is for men, and then our women. So I want to sort of put this into context. So one of the things, this is our control group who are in their 60s, and these are our individuals with the Myasthenia Gravis. So they are less fit. When Social Security looks at disability for people who have COPD, or have people heard that term? It's a lung disease where people are smoking and often they'll need inhalers to help breathing. Their fitness levels, when they drop below 17.5, they meet the criteria for Social Security disability because they're so unfit. Activities of daily living, and these are things like washing dishes, preparing a meal, grooming, putting your clothes on. They take energy. And the energy level is about 9 to about 17 milliliters per kilogram. That's the amount of oxygen required to do these tasks. So let's put this into perspective. So at 60, this is running the max. This is being able, let's just turn off.
Yeah.
You should be good.
There we go. Good. Thank you very much. So if you're 60, that's how much peak energy you have. You've got a lot of reserve to do your activities of daily living. How about if you're right there? We get this peak test by having people walk on a treadmill as fast as they can. Lance would ride a bike or run at his all out. There's not a lot of reserve. And that's the blue line. The next thing we do is we have individuals walk at their comfortable speed. So they decide where they're comfortable, they're not pushing, and then we take 90% of that, and we have them walk on a treadmill, and we measure the oxygen used. Well, our community group, it's about 8 milliliters per kilogram. So we have two values. This is where they walk comfortably, and this is their peak. We call that a fitness reserve. So when they want to go to the store, they want to do their errands, they've got a lot of reserve to do that. Look what happens with the myasthenia. This is their self-selected walking speed. This is where they're comfortable, and this is how much oxygen it takes to walk. And this is going full out. So that reserve just isn't there. And we're into that range where it's going to be hard to sustain the activities of daily living. So this explains some of that fatigue component. And it's, that we are always trying to put our handle on, you're good, you can do the one-time strength in the office, but you still have fatigue. So this is a way to look at that. So this is the sort of the baseline study before we do the exercise. We have to first define the problem. So daily steps are about 1/7 of what's recommended. The cardiovascular fitness levels are about 20% below what other community folks have. And then that fitness reserve is about 60%, they work at 66% of the peak, which is twice where age-matched individuals are. So how many of you on steroids gain weight, but you're not eating. I hear this, yeah, I hear it all the time, but I don't eat. Well, it may not be that you're overeating. It may be that low energy expenditure plus a normal diet may be what drives that obesity. So, who knows who this guy is? Jack LaLanne, and he just passed away recently. And this is him, I guess, in his 20s or so. So there are many health benefits, and he is really the king of physical fitness. So the picture behind him shows you there's definitely benefits for muscle composition. Mr. Hoffman was lifting weights, and he's excited about how much weight he's lifting. You would look like that? How's that? One of the things I think, muscle composition, yeah, it's great to look nice, but it's more, for me, about the metabolism of that muscle and what that muscle will be capable of, especially in terms of diabetes risk and health risk. But functional performance, so if we can improve function, great. In terms of exercise, there are benefits for blood pressure, glucose, lipids, and bone density. It's to keep active, keeps those bones healthy. There's benefits to mood. There's benefits to sleep. Remember when our parents sent us out to run all day and we slept well? And then healthy people 2020 aren't just looking at people who are aging well. We're looking at other conditions. We're looking at stroke and Parkinson's disease, people with different types of disability. It's going to be important for us all to be active as we're aging. So what are the recommendations? Well, this is what you can find out on the internet. So the first thing you need to do is, before you engage in exercise, is make sure the myasthenia is actively managed and that you're stable. Because you really don't want to be pushing at a time where the disease is not controlled. You don't want to exercise under crisis or a time of exacerbation. And common sense, you want to check with your doctor. Make sure there's no reasons that you shouldn't be exercising or modifying your exercise. And this is a time where you need to start self-reflecting. As you start into an exercise program, you've got to consider where you're at, your total daily activity tolerance. So if you go out one day and just start this exercise program full force, what's going to happen to you? You're going to crash, and it's going to take 3 days to recover. So you got to go into it smart. You got to start slow, and you have to know what you can do before you start the exercise program, before you start adding new things on. And then think about the energy required for exercise, because it may affect what you do later in the day. So what is the literature? Well, I could find about 4 studies of myasthenia gravis and exercise. Actually, there's 5. There's one on a single person, so it doesn't quite meet the mustard for what I'm looking at. So there was a resistive training program. No one knew what would happen as people with MG started exercising. So they had 11 people with mild to moderate myasthenia, and they had them lift weights on one side of their body, while the other side did nothing. And so what they found is that when they did biceps, there was no improvement in strength, but and triceps, but the legs got stronger. And what's most important? They didn't get worse. So it was safe. And that's, I think, the first thing, is make sure it's not going to do harm. They did 3 times a week for 10 weeks, and the leg strength got better. The only place that there was a randomized study was one of the lung exercises. So there are 3 studies in the literature on pulmonary rehabilitation. So how many of you get shortness of breath? How many of you get short of breath when you exercise or when you push a little faster? You can do everything you want, but if you go faster or you go beyond where your body wants you to, you start getting winded. Well, there are ways to improve the efficiency of breathing. So one of the things that people do are pursed lip breathing. So you breathe in through your nose, and you blow out through a pursed lip. And so training the body in more economical ways to breathe actually were beneficial. Also, teaching people how to use their diaphragm. If I asked you to put your hand on your tummy, and we're all going to do this before food, and then take a deep breath from your diaphragm. I kind of want to watch as you do it. How would you do it? I actually saw a few good ones, so someone's been training folks. So most people, when they take a diaphragm breath, they think you breathe in this way, but I see a lot of nose. You actually learn to blow out. So as you take a deep breath in, your tummy goes out, which doesn't make sense, but that's the way the diaphragm works. So learning how to engage those muscles. The intercostals help us breathe, so learning how to engage the rib cage. So one randomized study, so placebo, they got nothing, or they got pulmonary exercise. The placebo group got to come in and they got engaged with healthcare professionals. The breathing exercise did better. Now guess what they found? If you don't keep it up, what happens? You lose it. You use it or you lose it. But people didn't go back to their baseline. They still were a little better than when they started, when they looked later. And so there were two other non-randomized studies that showed breathing exercises could improve. There are no studies of aerobic training. So that walking and that portion of getting the heart rate up. So that was something that I thought we might want to do. So our hypothesis was, would a 3-month exercise program improve functional performance and fitness, and would it be safe in individuals with myasthenia gravis? And the aims were to see if it's safe and feasible, well, actually almost the same as the hypothesis here. So for this, people had to have myasthenia that was well controlled and without medication change for 3 months. This is a non-controlled study. It's a pilot to see if it's feasible. And so in the first cohort, and you can see some places I have 6 and some I have 7. We've been adding individuals as they've been coming in. I've had 3 men and 4 women so far, and a new cohort starting. And their mean age was about 63. They came in 3 times a week, and the total exercise session was about 1 hour. And it included 3 things: treadmill walking, strength training, and instead of doing machines, we did TheraBands so we could work across joints to minimize the fatigue and we could work more efficiently. And then it included breathing exercises. The first 2 weeks were every day in the gym, so 3 days a week. And thereafter, they came in 1 day to the gym, or they could come in 3 days a week. And if they wanted, they could do the other 2 days at home with an exercise logbook. Before starting this, because this is a new protocol, and not knowing what the safety of this, we got doctors' approval to come in, but we also did a treadmill cardiac stress test, just to make sure everyone would be safe. And then we actually did an exercise program that was based on heart rate intensity. We started at 40% of their heart rate reserve. So this is a little exercise you can do, and I don't know if you got pencils at the table. But to figure out where your peak exercise would be predicted, you do 220 minus your age. So if you are 60, it would be 160 would be your peak heart rate. Then you take your resting heart rate, and we'll say it's 70. So what we do is we take the peak minus the resting, and that's the range that we know we have to work from. But we don't want to go all out to start with. So this is something they do in cardiac rehab. So we start low intensity, so about 40%. So that would be taking people to about 100 of heart rate. If you were at 70 to about 100 to start. So we have a little response. And then through the course of the 3 months, We gradually built on that to get to about 70% heart rate reserve. Individuals started at 15 minutes, and we did it on a treadmill, and because so that people could feel intensity of walking, and some of them had to take breaks for that 15 minutes. So we'd walk 3 minutes, we'd sit down on a chair on the treadmill, and we'd get back up and we'd do it. So we eventually got to 15 minutes. But by the end, everyone was walking 30 minutes. And we used a heart rate monitor so people could feel the intensity. We were talking, someone was told they need to sweat to know they're doing exercise. So we did it a little bit more objectively. So in doing the program, we also looked at blood pressure coming in, and at the end, we looked at the pulse, and they wore heart rate monitors so we knew the intensity of exercise. In people with diabetes, we looked at glucose before and after, because as you exercise, you're going to drop your sugar. We did not want to get hypoglycemia precipitated by the exercise. And then we do it based on the level of exertion. So we asked people how hard they felt they were working. And we started with low, and we wanted some exertion as they worked through the program. And most importantly, we were looking at the MG symptoms. If they were bad coming in, we don't want them exercising. If you're so fatigued, don't make matters worse. We asked them midpoint in exercise. We asked them when they were finished. We also asked them what were they like at the end of the day and the next day. Because how many of you have overdone it and that next day it's sort of like, I can't get out of bed. And you have to pay the price. Well, that's too much. So it's the reason that you want some feedback with this is so that you don't get into those awkward situations. So our criteria were over 20, that myasthenia gravis had to be confirmed, the MG had to be stable, and because it's a supervised program, it's the first one, we want success so that we can give good recommendations. We're doing it under our supervision in Baltimore. Because I've had so many people calling, I want to do it in California. It's like, but we need to see the program. Exclusion or anything that would preclude exercise. And the only reason I have pregnancy on here is because of the x-rays that we do. We don't want radiation exposure. The outcomes I'm going to show you. So with the treadmill training, the workload, we look at METs in terms of cardiac workload. Individuals were able to increase the amount of time they were able to walk. The speed went from about 1.8 to 3 miles per hour. The grade, they were able to walk with some elevation. Their exertion levels went from low moderate to moderate, and we got a cardiac conditioning heart rate that we were expecting to get. We didn't have adverse events, about 80% attendance and logbook integrity, and many of the people wanted to keep this going once the program ended. In terms of functional improvements, that short walk, they went from 2.3 miles per hour to 3 miles per hour. Well, that little bit of speed can make a difference in terms of getting things done at home. 6-minute distance, they were able to go from 1,600 to about 1,900 feet, which means they could cover more ground in 6 minutes, which is about what time it takes to go in and get your prescriptions. These are small community tasks, which is why this is a nice distance. The get up and go, getting out of a chair, the time dropped. Strength, we measured on resistive training machines, and I had some large men who actually skewed my numbers to very high, it's actually newtons, but strength increased. And the quantitative MG test didn't change, but I think as we start getting more individuals, my statistics might be better. But they didn't get worse, so this is important. The fitness didn't change. I was expecting them to be so much more fit. Well, it's a 3-month program, and I'm okay with the fitness not changing, because if you look, even though they use the same amount of oxygen, their walking speed went from 1.9 miles per hour to 2.6 miles per hour. The METs reflects what their speed was and the elevation. That increased. So the workload capacity increased for that same fitness level. And the other thing that happened was the amount of air they could move in a minute while they were doing these tasks went from 60 or 77 liters per minute to 91. So they were able to keep up with the respiratory capacity. And this is the economy, that efficiency. This is where I think we made the best gains, is the amount of oxygen it takes to walk at a comfortable speed went from 15 to 11. So these individuals were more efficient. Their heart rate didn't get taxed as much, so the heart rate isn't as high. They didn't need to move as much air to walk that comfortable speed. And then the percent of their peak went from 68 to 50. So there's more reserve. And this is my final slide, is we looked at glucose tolerance. So I'm very interested in, we're part of a geriatrics group that looks at diabetes. So how many of you had a glucose tolerance test? I saw about a third of you. So with the inactivity, with the steroids, there's a greater risk for diabetes. And often the first thing we want to do is look at pre-diabetes. So it's called insulin resistance. The best place to dispose of sugar is in the muscles. And so as we become less active, we don't dispose of sugar as well. So when we eat, the sugar goes high, as you can see here. The pancreas responds and puts out insulin. Well, if you can't drive the sugar into the muscle, you're insulin resistant. So as you get more muscle mass and as the muscle is more active, it becomes more efficient as getting rid of the sugar, and you don't have to put out as much insulin. So you make yourself more sensitive. So the blue is what's happening before the exercise program, and we can see that disposal of glucose is starting to show some trends. So it looks like we may be affecting some glucose tolerance. And this is only on 5 people, so it's not enough to make health decisions, but it's the response we wanted to see. So conclusions, it appears that this exercise program is well tolerated and stable MG. Function, we were seeing some improvements. Fitness, although it didn't change, people looked like they were able to do more work, and they were more efficient at their economy of gait. So what do we need? We need larger numbers. We have to be able to end a wider range of MG to really generalize this program and to understand its benefits for health and function. So it takes a lot of people, and as you said, the most important thing is the dedication of the people who actually participated in the program going through this research. And I was funded on a pilot study from the Myasthenia Gravis Foundation. So, thank you.
We started back in the early part of this year, and we're still not up, which I can thank my university for. It's very difficult to negotiate with a university, even when you want to give them money. It's amazing. But nothing happens until contracts are signed. And I must say that the MGFA, who will be funding the registry initially, have been incredibly easy to work with, accommodating, etc. And it's just taken more time than it should have. But we're finally to the point where we can just about start. So I want to explain a little bit about what does a registry do, why would you have a registry, and I may use another registry that I have, which is a multiple sclerosis registry that's been in existence now since the mid-90s. And we're beginning to really get many, many things out of it. One of the things I should tell you is when the registry started, that registry, there was a lot of thought that you couldn't get much from patients, that you needed the clinicians to be able to get good, valuable information. And I was recently at an international meeting of the clinical trials group in MS, which is made up of clinicians. and they are now wanting to use the NARCOM registry because they realize that there's two sides to the coin. And we get different information, both of which are valuable. And that's what I hope to convince you. So I'm going to tell you, how does it work? What we do, when I say range of services, not what we provide, but who uses this. What kind of collaborators are interested in having a registry, including yourselves. And then I'll go through what's called the NARCOMS registry, which stands, you'll hear about NARCOMS and what we do with that. And again, you should feel free to interrupt me because, this is your stuff. The range of services that happens from a registry, the most important, I think, from your perspective is provide information of interest to you. So what I'm going to do when I finish running through these slides, I actually have a draft of the questionnaire we're going to use in MG, not for you to fill out or not for you to even do anything with, but to think about what information would you like. One of the things that I just learned is I'd love to know how much exercise everybody's doing and be able to track that. We did not include that in the way that I think it could be done to actually provide a measure. But it is important to get information that's valuable to you, and one of the functions of a registry is periodically return some of that information. Studies. You can volunteer for studies, but we might become aware of studies through the registry and can email individuals if you sort of belong to a registry to say, here's a study. We will not, and you'll hear me say this a number of times, give your name to somebody else. The idea is we're an intermediary. We do respect the fact that this is privileged information, but we're a vehicle for you, so there is a point of contact that someone can come to that says, how would I get MG patients? How could I contact them? And your association is of course a valuable way to do it, but there's other ways that we can use information that we would know from the registry and not bother everybody with another blanket email that might end up in your spam box. The selection of knowing about individuals to target them with unique things can also speed the amount of time on the other end for someone who's requesting it, so it doesn't waste your time talking to somebody for an hour only to find out that you're not eligible. The data collection that we do is done online. We do not sell information or give information to companies or market research firms. We've had offers, but we don't do that. The reason is that this is a contract, in essence, between you signing up and us managing the data for the benefit of the participants in the registry and for scientific uses. That doesn't mean that a pharmaceutical company doesn't want to use the aggregate data to find out what's the distribution of the stage of patients over time, or how fast does it change. They can use that to design studies. That's not giving individual information that's going to come back in an ad that says, guess what, you should buy this. It's separate, but it's important to keep in mind. We do this online. In the NARCOMS registry, which I'll talk about in a minute again, we actually do some paper forms. That's a very expensive and cumbersome way because we have to mail them out, we get them back, we have to enter them, and it's cumbersome. We do about 3,000 to 4,000 of those. We get our best response rate from that subgroup, otherwise we would have stopped. We get about 80% response rate on our questionnaires that we send to the participants that way, and we get about 70% from our online cohort. We get data sets that we can share with investigators, but they are aggregate data only and they're de-identified in a way that protects your individual privacy. Most people don't want it for any purpose other than to find out what proportion of people have X, Y, or Z. But we do a number of things to make sure that it's not identifiable. And what you see up there, it says IRB approval. We have all institutions and people who do research have to go through an institutional review board that looks at what you plan to do with each and every questionnaire, what kind of advertising to get people involved, and they review it and say, no, you have a potential to harm somebody, and harm comes in many ways. Obviously, filling out a questionnaire is not going to harm you directly. I guess if it was psychologically harmful, someone would pick that up. But there is a level of care in making sure that we don't bother people either too much with too much information. So there's a fine line to how long the questionnaires can be. And of course, ultimately, it's your choice to complete them. But still, someone looks at that beforehand, before it ever gets to you, to try, it sounds very paternalistic, they're going to try and protect you. But they do have an obligation to make sure that what we're doing doesn't cross a line. No one knows where that line is, but it's good to have an independent group that has no stock in the project, making sure that something that you think might be valuable as a researcher doesn't cross over a line that says to an average person, this doesn't make sense. So you don't ask questions about X, Y, or Z. And that happens frequently. So who can collaborate with us? MGFA members, participants. There's information that you may request and you might want to know from a registry just for your for some thought, some planning, some topic. The registry would be available to give that. Clinician researchers will use this, nonprofit organizations, government agencies. With the MS registry, there's talk of having a national MS registry sponsored by the federal government. And they came to us to try and figure out how much do they already know about it? How easy is it to detect MS patients in the community? And through us, they found out that it's not very easy at all. That utilizing registries such as this is a reasonable way to get good coverage, but just trying to get, who wants to register with the government? Well, they've got my tax ID, what else do they need? So you can see a whole range of individuals. We've had, in the use of the NARCOMS registry, what I call the North American Research Consortium on MS, we've had multiple people. I stuck 3 up there just for the sake of it. There's been quite a bit more. People use the registry to recruit for a particular study. We've had data collection where people are trying to get additional information. The one that I'm familiar with is this one. The care partner was trying to get at what kinds of burdens could an organization, a not-for-profit, the Consortium of MS Centers in this case, could they offer to patients that might help the care partner in some of their dilemma. Other ones, analyses, we've done quite a number of those, and I'll run through a list of topics a little bit later. Other examples, Cleveland Clinic has come to us, UT Austin. These are specific projects that individuals had on their plate. They wanted to use MS patients in there, and they wanted to be able to have a centralized source so they weren't just picking patients that they knew in their communities. We're a nationally represented organization. Are we representative in a U.S. Census sense? Of course not. It's volunteer. So whenever you have volunteers, there's differences between people who volunteer and people who don't. And that's okay. There are problems that come with that. We might not know about the less severe patients. We tend not to get a lot of the newly diagnosed patients registering in a registry because it takes time to sort of, in MS, and I suspect it's true here, that initially you're not joining an organization. You're going for information, but you're not joining an organization. You want someone to take care of this, want it to go away. When you get over that and you want to participate in an organization, it becomes more likely. When we look at the distribution of the stage of disease in our MS patients, we can see we're missing some of the very early new diagnosed patients. It wasn't a surprise, but it helps us understand that we have limitations when we make statements about what new patients would be taking as medications and reporting on that. We don't have as many as we should. So nonprofit organizations come to us. The National MS Society has come to us to compare to one of their studies. They're called the SLIFTIS study, where they examine people. So they have clinic measurements on individuals, but they have more dropouts than we do. Recruitment assistance, they've come to us for that. And they are talking with us about how can we recruit newly diagnosed patients, because they have the same problem. They're an organization. They want to have a good registry of patients, And the issue is we're missing the new patients where the information may actually be of more value than with patients who've had the disease for 20 years. Not that it's not valuable for people with a disease for 20 years, but it's different kind of information that may help those individuals make better choices early on in their disease. MS Plus is an international organization, and the Accelerated Cure Project is another not-for-profit that's working on issues for multiple sclerosis. So all of these other groups come to us for different kinds of information and often recruitment assistance. Government agencies, we work actually fairly closely with the VA. We had an initial, when we got started, a joint recruitment effort with the VA, and subsequently we have published papers about what are the differences between veterans who volunteer into a registry separate from being actually in the clinic, and are there differences, and what kind of differences are those? I mentioned the CDC and the idea of a national registry, and it's through the Agency of Toxic Substances and Disease Research that the investigation of the National Registry was undertaken, and we've worked closely with them. In fact, there's a poster presentation at the American Public Health Association meeting that's going on this weekend in San Francisco with them. We have academic collaborators. Academics like to do studies and publish papers, so they come to us because we have data. Many of them just don't, and collecting data de novo is very expensive. So we offer an opportunity to be able to investigate someone's idea either by adding a question to one of our questionnaires or a page of questions, and we can get things done in collaboration with them that, again, speeds research in a way. Trying to get money to do a grant on your own can take, if you're going to, for example, the NIH, it can take 3 to 5 years to get funded. The thymectomy trial took 5 years to get funded. And it's an arduous process to get someone to give you a lot of money. It's a fair process. I'm not moaning about it. I'm just talking about how long it takes. I started many years ago. Still working at it. We have some other problems that are kind of interesting. One major source, and we had the best resource for Dr. Hauser. He is a neurologist who does MS research. He's chair of neurology at University of California, San Francisco. And he was interested in looking at genetic susceptibility in MS. So we were able to inform participants in the registry, and they responded directly to him. We were just the marriage broker. Once someone wants to be involved in a study, it's, we've made it available. You contact, here's how you get involved, but we've arranged for the involvement. And he had the best response rate from any group through using the registry. We're involved in, MS, in a sense like MG, is not really a fatal disease. There's a risk of death, of course. Ultimately, even without disease, you have a risk of death. But we have 36,000 patients in the MG registry, in the MS registry, and over 10% of them have died. And we're in the process of looking at that. I mean, the registry goes back 15 years, and it's not surprising that people die. It happens in clinical trials where you're doing drug studies, but usually there's only a handful. The average age of patients who get diagnosed is in the 30s, have a familiar ring to it. So you don't expect or see a lot of mortality in trials or as you're studying individuals, even in clinic populations. But when you have a registry and follow people, and it's now 15 years later, well, the individuals who started off at 45 are now 60, and you're getting into a risk period where death occurs. What we're looking at is causes of death. So not only have we seen that 10% of our cohort has died, which is also information in terms of why they've dropped out and are not responding to our questionnaires, it provides us an opportunity to look at cause of death, and many of which are MS related, and we can report on that. Some other examples, people have used us, again, mostly for recruitment assistance in these other categories, looking at healthcare issues for AIDS, CPR, and people try to get information without, if you're trying to find an MG patient, you're random digit dialing, Number one, most people aren't going to answer the phone, certainly at least for 2 months after this election anyway. And just think you actually don't live in a state that's half red and half blue. I live in a state with only one color, but so we've been spared the phone calls. But trying to call and find through random digit dialing is very inefficient. You waste a lot of calls and it bothers a lot of people, which is not good for anybody. So we've done a lot of projects with the pharmaceutical industry. We are involved in a mortality surveillance, as I pointed out, with one company that actually published a paper recently that showed with treatment with their interferon drug, 2 of the groups that were treated with interferon early for a couple of years, 3 to 5, had less mortality at 21 years than the group that was initially on the placebo arm. Now, nobody knows whether that's real or whether or not it's just a quirk that the placebo group just misbehaved and died more often. But it could actually be very important and something that's quite important. So we're trying to look at some of our data to follow that up because it might tell a lot of good information. Other things people are looking at is what makes people switch drugs, why do they change, who's really in charge of the information. We recently presented at an MS meeting that the greatest source of information for most of the participants in NARCOMs is the internet. Not a surprise, but the most trusted source of information in 90% of the patients was still their physician. And we think that's very important information in terms of, what the balance is and what the interdigitation is between the internet and the physician and how that information can be used. So we have many data sets. We generally get 4,000 to 10,000 on any one response. I said we had 36,000 in there. We have special topic surveys where there's something that's a specific, that doesn't affect everybody. So we did, for example, a risk tolerance. How much risk will you take to possibly cure your disease? So if I have a drug and the outcome is you're either going to cure your disease or die, will you take it? And you can go back and forth. What you do is, it's called a standard gamble, and you get people to sort of balance the risk and where's that risk. And the reason we did this was funded by the MS Society, but there is an MS drug that has a risk of a very bad brain disease of at least 1 in 1,000. And if you're on the drug for multiple years, it goes up quite a bit. And we wanted to find out where's the break point. And we learned 2 things. One was that the break point for most people is about a risk of 1 in 1,000. And the secondary thing that we learned is the more severely disabled you are, the more you're willing to take more risks. Now, it's obvious after the fact. But because this disease has a risk of at least 1 in 1,000, became a very interesting number to pick up and try to see what do you do with a drug that has these. And many of the newer drugs do have these rare but untoward side effects. So what do we do with the data? Well, if somebody comes to us for data, the first thing they have to do is they sign a confidential disclosure agreement. And that makes sure that, they and us, we talk about things, and we know that people are going to tell us that they're going to keep the data confidential. But we want to pursue that, and we want to have sort of, it's not a legal agreement, but it's certainly an ethical agreement. And we try to make sure that nobody is going to sell data and take data beyond where it's, and the use of that data is restricted. They can't use it just indefinitely. There is a complete understanding of what they want to do with that data. Does that mean they can't generate another table that they didn't tell us in advance? The answer is no. I mean, we're not trying to make somebody all-knowing before they come in and say exactly what they're going to do, but what we're asking of them is to treat the data with the care that we demand, that they can't just use it, give to 5 graduate students to go off and publish without us knowing about it. The data belongs to the patients, and it belongs to the MGFA, and we have to protect that with what it's worth. What we do in terms of giving back to the participants in the study is we have a magazine. It's nothing special. See, that's a cover. And we do various things. We try to give back some of the data that we've collected in snapshots. We try to highlight different things that are going on in the research arena and provide a little more in-depth stories. Some of the investigators write a little column about what they want to talk about. This is one of the lead investigators I work with. She's in Canada. So it brings up perspectives from all around the world. We talk a little bit about a survey and what does it mean? Why did we ask certain questions? Sometimes we have an 800 number, and we get feedback that says, why did you ask that? Why are you asking me whether or not, I use health information sources not related to, Sometimes we have to explain a little bit about why we've done something. Now that doesn't mean we don't explain it when someone calls, but if we get enough questions about something, we feel like there's a lot of people who didn't call us or take the time, but they still are wondering. So we have an obligation to explain to you why we did something. We try with anything that is a little bit off the ordinary to explain it when we're doing it. But again, we oftentimes understand what we're doing, we don't explain it well. So the magazine provides a way to explain things where we actually haven't done as well as we thought we would. We have question and answers on topics that come up, and those are often generated by questions that come to us, or hot topics that may have occurred in between magazines, but maybe got a lot of press, and sometimes the 30-second snippet that's on the nightly news isn't the full story. It's not that we're the Oracle at Delphi and know the right answer, but we can point out at least some of what might not have been said in an article that appeared on the news at 6 o'clock. I've just got a snippet of some of the publications. As you can see, we looked at bone health, MS, their relapses are treated with prednisone as well, and in high dose, so they have some of the same concerns. We looked at racial differences in how the disease affects different races. We've looked at alternative medicine use. People try a lot of things. We had a survey where we actually tried to figure out, what else are you doing? Sometimes other things are good or not good. We just want to know what it was, and we have a list of what people are on. We can see by combining it whether it has any potential effect, because we measure disability in a patient-reported way. We looked at smoking, which very few diseases are benefited by smoking. There are a couple, by the way, but not this one. We looked at the loss of mobility on activities of daily living, and how does that affect patients with MS. We've looked at visual and vascular comorbidities that occur in MS. Again, people forget about the other diseases. We got interested in this, of course. When you start thinking about mortality, well, as people get into their 60s and 70s, they're going to die of cardiovascular disease. And if you don't know about it, and you're only thinking about MS, well, you're going to miss some of that. And as I just pointed out, exercise plays into this quite a bit, and there's a fair amount of vascular comorbidity in MS. I mentioned the survival, and we've also been following something that is the reverse of what may be going on in MG. In MS, there has been an increase in the sex ratio over time, going back probably to the 40s, but at least documented from the 50s on, more and more females to males. Now, we presented this about 5 or 6 years ago, and the response was, well, women just underreported it. I won't go with that one too long, but we've been able to trace this down, not only in our registry, but worldwide, that the ratio went from about 1 to 1, almost 75 years ago, to where it's 3 or 4 to 1 now, and nobody has any explanation. Nobody I know has any explanation. If anybody does, I'll get it. Now, we think in MG there may be an increase in males, in older males, that are developing MG in their 60s. We've seen that in our screen population. I have no idea if it's real, but it's the kind of thing that you can look at in a registry in a variety of ways, because you can look at when somebody is diagnosed in their age and separate what are called cohorts from cross-sections. So when you go to our website, The one for MG will look similar. You can imagine why. We have the infrastructure already built to collect everything. It'll look pretty much like this. You can click on any of these and it takes you inside. It's password protected. You have the password, so no one can get to your data. Some of you will forget the password. That's why we have an 800 number or a way to get your password back. We do a lot of that. And then each of the individual things, there's an area for information, there's an area with links to other places for sources of information, and there's an area for every 6 months we will have a questionnaire. The questionnaire will consist of a standard portion and then some special topic. And the special topics come from researchers who have a specific interest in a particular question, or patients. You can get us to put something in there that you're interested in. And the advantage of having a 6-month questionnaire is that we can get information from people in a much quicker way than you can do research where you can't get stuff done in 6 months. It just takes too long. So we have a very rapid system to be able to get information out. We keep it out there. You don't have to respond on Tuesday. It's generally out for a month to 2 months. And we'll send reminders, a few of the mechanisms like that. And I think in the end, having that consistent information that we collect over time on individuals allows us to get a snapshot of the longitudinal nature of the disease, which is what you don't get in the survey. So a registry can benefit participants and research, rapidly collecting information, special topics, in a way that we really can't do it quite easily without some mechanism already in place. We can get direct notification, but it's private, and it's not a public display of information. And the longitudinal assessments are incredibly valuable in saying what works, what doesn't work, and what do we know about how fast or how little people change. So that's all I have. I do have, just to let you know that this is not we do have a draft questionnaire, which is obviously too large. You can't read this. There's no reason to do. This just goes into what the information is. This is like the registration form. So there's, I should have put this in PowerPoint, but here, do it this way. Maybe that's a little better. Just have demographics, some information about where did you spend some of your time as a child. In some diseases, if you, like in MS, for example, if you lived at a northern latitude before you were 16, you have a higher risk of MS than if you were below the 42nd latitude. And it goes away if you move, if you move, and so that there's, some people think it's a vitamin D hypothesis. There's a variety of reasons and thoughts about it. But I mean, it's the kind of information of why you would want to know where somebody grew up. So trying to get to the etiology of the disease just hints at it. This will go on for many pages, a little bit about health insurance, because some of this information can be used in the aggregate to talk about what are the problems in accessing care and getting it paid for. And we've begun, obviously, to have more and more inquiries. MS drugs have gotten enormously expensive, in the neighborhood of $40,000 to $50,000 per year. So, I mean, it becomes a big issue, and healthcare in this country is a big issue. So it's a good way to get patient-level information about what's going on. We have a lot of muscle-specific kinds of things, MuSK antibodies, and things that you may or may not know. And I'm not going to go through the questionnaire. You'll hopefully see it soon enough. And I'd rather take your questions. I can go back to some of these. But you can see this is about it's about a 20-page form. It takes more screens on a computer. This has got 24 pages, but some of them are boilerplate that actually can appear in other places. So the idea would be you would register, there'd be a registration form, then you get to experience us every 6 months if you put up with us, fill out questionnaires, and we will build a large national registry of MG patients. And there's nothing to keep us from doing this internationally. There is an effort that's going on internationally through a group in Italy. They're starting off with the clinician side of it, trying to keep patient records from their record systems. But I think there's information that we collect from patients that physicians don't have. So it's good to have both. We'd like to be able to link it to clinical data, but that's a separate thing that we'll get to down the line. We have to show that this is feasible.
What's the website?
It will probably be www.mgfaregistry.org. Don't write it down, it doesn't exist yet.
Now that the contract is done, right?
Yeah.
The attorneys have kind of worked through it and all.
Well, I can't pick on attorneys, as you know. I have a daughter who's an attorney, so I have to bite my tongue a little bit when I talk about the evil of attorneys. But there are some folks in my administrative offices at the university that it's amazing what will hang up. This one was, I think, hung up mostly over intellectual property, which is a reasonable thing to be concerned about if I was trying to make money off of all of you, but we're not. And but I think it's done, and we've got a target date to try and launch the first of the year, not on January 1st, but sometime between January, February, or March, we'll be up, and we'll let you know.
So they're still working through, and we'll let you know about it once it gets up and running.
Well,
So,
members of MGFA automatically receive it.
if you're on the mailing list, I'm sure.
You'll receive notification that it exists, and we want everybody who's with MGFA, of course, to sign up. But that's an individual choice. So you will volunteer by registering and being part of it. You will get notified. There'll probably be a link on the MGFA website to click on it and join the registry, and more blurb about the registry, because in essence they're supporting it. But I think, again, individually, it does benefit everyone, I think, collectively. The greater coverage we have and the more people respond, the better off it is. But we won't consider you out of the registry if you're on vacation, you forgot to respond. We might send you a reminder or two. But again, the response rate is what makes the quality of the registry. So it's made up by contributions from all of you.
Can you say something about what the experience is of somebody who will be on the registry? You fill out a questionnaire to begin with, and you get some newsletters, and then how often do we get contacted by you or others who are doing research?
I can give you the MS example. Initially, it was floundering. We've got a lot of expertise on how to get started now. The registration has a certain form that gets historical information that we only want to collect once. Other information is information of how you changed, and we use a 6-month interval. And we use a 6-month interval because it's too easy to forget about us if we wait for a year. Most things don't change. Some things are useful to get at 6-month intervals. And that gives us at least 2 chances to have at least one measure each year for somebody who's been in the registry. That's very useful. So we've just done a study of how many people switch drugs over a 5-year period, because that's an economic issue and a variety of other things. So it becomes more valuable the more time we have. You will get, we're hoping to put together this newsletter that will be mailed to you, emailed. We can email it. We haven't decided whether we're going to use print or PDF type mail. I don't think, given the amount of research that's going on in MG, I don't think you're going to be bothered by people wanting to use this recruitment very often. I think there'll be a handful of opportunities per year if we can get things moving. We have more botheration in the narcotics registry to the participants because of special topics like switching drugs, like how many individuals do you have on this drug. That was actually a research question from the FDA a drug called myoxantrone is used in MS, and has some recommendations that once you've been exposed to it, you have to have annual cardiovascular evaluations, and they're trying to get a handle on whether people are doing them. So, that's a special study. So those special studies will occur more frequently once the registry is more mature. So in the first few years, I suspect you'll almost not know we're there except what we send you. Maybe 1 or 2 studies. It would be great if we got overrun with opportunities for people to be involved in studies. I can see the first one I can see coming is we could gladly help try to encourage a national exercise trial. I personally think it would be really interesting, and I think, you're capturing individuals. You've already got, when people you contact over a registry, you've already gotten over one hurdle. People who tend to volunteer, who give of their time for the benefit of others, even though they're getting something out of it, they're more likely to volunteer for a trial or a study. And therefore, it really, the research funders in this country, NIH, for example, and the National Science Foundation, are cutting trials off. As good as the idea was, if they didn't meet their recruitment goals, they're saying goodbye. And that's all wasted energy by all of us, by patients who've already agreed to participate. I mean, it's unethical to do a study if you can't get an answer to it. And therefore, this may help move research in a fundamental way.
Yeah, question. I realize I'm excited about this database, but one of the things that we as MG patients, we need a database of physicians. And I realize it's not as politically correct, but those that have expertise and a lot of experience in treating the MG patients. The problem is so many of us just go to the general neurologist and they have basic textbook knowledge of MG, and they won't diagnose the zero-negative patients, and we get improper care a lot of the times. We need a database of physicians that have the expertise, have an MG clinic. I travel 300 miles to see my MG doctor just because my local doctors have no knowledge. And I was treated for a year and continually got worse.
Before Charlene answers that, if anybody has any questions written down, I'm going to come around to pick them up. So if y'all could hold on.
I saw those eyes going, oh. So that's one of the things that you asked. The first question you asked is there a repository of myasthenia gravis experts? The Myasthenia Gravis Foundation of America has asked the Medical Scientific Advisory Board to put out a list. I can't tell you go see this person from a legal standpoint. So what they're going to do is people that are on the Medical Scientific Advisory Board, we're going to have their names available, and these are people who do both research as well as clinical care for myasthenia gravis. So it's a good place to start. The other place it's a good place to start is you come together as a support group, and trial and error have shown you some good places to get care and bad places to get care. And it helps
We do
to
that
get
as a community
recommendations.
now. Daily Strength, a lot of us do that now.
Right.
But
So it's a good place to start. Now, the second question was, I got lost. Give me just a, what was, oh, getting your general neurologist. That's something that I think it has to go back to your court. So myasthenia gravis is a very complicated disease. And one size does not fit all. It's not like taking care of cholesterol, and so if you're not, as Gary said, we are all science experiments within yourself. So we put you on a drug, you get it's balancing risk and benefit, and when one drug doesn't work, you try the next one. If you're not getting what you need to get a second opinion. And you might be better off with your first one. You don't know till trial and error. I don't know if that helps.
I'm supposed to ask this question. This is good because I can just ask a question. What percentage here are positive or seronegative?
So who's seropositive? How many of the positive antibodies have?
I think they pretty much have to be.
If you had a blood test,
Unknown is an okay response.
and then how many people do not have any antibodies, so you're seronegative,
They can't pick them up.
or they have not found the, so it's almost about half and half.
Well, that's something, we were talking at the break about, whether somebody will count you as an MG patient if you're seronegative. And one place to capture that, and that's one thing that we can get in a register. How often does this occur? A lot of it has to do with the quality of the antibody testing, as I'm been educated. One, as you, I guess, said, or they couldn't detect it. That may be one issue, but we could ask that question in general, and I think it'd be a good one to have, and then see how it changes over time. Awesome.
But, so in terms of antibodies, there are several that we're looking at, and I have a question on mine. So one of the more common antibodies is the acetylcholine receptor. So on the nerve, when you want to move, your brain says move, it goes through the spinal cord, it comes out of nerve, you have to send an electrical message over to the muscle. And the way that you do it is you release from the nerve something called acetylcholine. And it's picked up on the muscle. And it's picked up at the acetylcholine receptor. Most labs will do an acetylcholine receptor binding antibody. So when your primary sends off an acetylcholine receptor, it's usually just for the binding. But there's binding, blocking, and modulating. There's striated muscle, and probably mid-90s, I lose track of time, there's a muscle-specific kinase, or MuSK. And those are the most common ones. So those are the antibodies. And if you ask your neurologist, they usually have that on your records.
On that, what's the difference between the binding and the modulating antibodies?
So there are different types of antibodies. So I think a lot of this came about in the labs. So when they looked at these antibodies, they found that if you take your antibodies with Myasthenia Gravis and you isolate them and you put them in an animal model, you can actually create Myasthenia Gravis. And they do it, the rabbits were a group of animals that got myasthenia the greatest, and so their little ears flop, and their legs get weak. So when they look, they're very cute rabbits, though, like these floppy ears. So sometimes the antibodies bind. It's what they do to the receptor, and so as these antibodies bind, sometimes they change configuration and change the way that the chemical message is transmitted. So it's how they affect the receptor. And so there are different types of action in the neuromuscular junction when they test these antibodies in an animal model. So it's the way the receptor responds.
Does Mestinon then attack each of the different types?
So Mestinon is actually a chemical that when the acetylcholine comes across and binds at the receptor, it creates a reaction at the muscle to cause the muscle to contract. Acetylcholine esterase takes that Mestinon that's bound at the receptor and removes it, and then it goes up and gets recycled. So Mestinon keeps the acetylcholine at the receptor longer. So it's acting on the receptor, not necessarily on the antibody. So the antibodies block your natural acetylcholine response, so the Mestinon allows you to have more at the receptor. Now, I got a question about galactin. So have you seen a connection with galactin-3 and myasthenia? And I get asked this in all my antibody-negative patients. I can't find this commercially available, so this is done in research settings, and so I don't have a lot of experience. So is that a good enough? So we will learn more as this becomes, I imagine, once it's more commercially available. So other things with the antibody negative, when they do they look for titers of the antibody. There's a tightness on how these antibodies bind to a dish. And now, in order to, they put the antibody, the serum, on a dish, it binds, and then it has this immunofluorescence. Some people with myasthenia gravis have a low avidity, or it doesn't bind so tight. And so Angela Vincent, as you had mentioned, is looking at individuals who are seronegative who have antibodies, but they don't bind tight enough to be detected. So she's looking at it in an animal model where she looks at these low binding capacity. They just don't hold as tight, but they have a functional effect on the acetylcholine receptor. Again, it's not commercially available, so we can't just send your bug to the lab. Yeah, you can send it to Angela, so you've got to get her vested, and it takes a while to get.
She's backlog.
Yeah.
So, okay,
And she's
on, I know one issue with trials is exclusion criteria, inclusion criteria. A lot of it is the seronegative and they've got the antibodies. That's not going to be a criteria for getting to the registry, is it?
No, absolutely not. We want everybody. And one of the criticisms we'll take early on from clinicians will be, how do you know they have myasthenia? And we'll accept that. And somewhere along the line, when we have a large enough we'll sample, as we did. We had the same problem with MS. And what we did is we went out and we wrote to the individuals. We asked them if they could contact their physicians. We went and had people review the records. And we showed that about 97% of the patients who had registered were indeed MS patients by standard criteria. And we tended to believe that most individuals don't want to be in a registry just to call themselves MS patients. And I think there'll be people who register who, and we've done, we get people who then say their diagnosis was a misdiagnosis and they go away. We keep track of that. So we want anybody to register, and certainly we'd like people to be accurate, but we can't even guarantee that at the clinical level. So we're going to accept this, and we know that the bulk of individuals that we'll have will be appropriately classed patients, and in the long run we'll have large enough numbers that in fact it will dominate any noise from people who just want to be part of something.
Just one comment I'd like to make, because we don't, at least in our case, we get a lot of face time with clinicians. But I think we really need to thank people like you, because if it wasn't a clinician at this university, UAB included everybody on the whole sphere, in the last 10, 15 years, we'd be nowhere from where we are now, as an observation.
I have another question. So the question was, what is the effect of food on MG? Well, I got to confess to you, I'm a neurologist. And so the exercise, I work as part of a geriatrics group, and I have a number of exercise physiologists. So I've been having fun. I actually had my midlife crisis, and I'm kind of solving my crisis. I'm learning a new whole area. So nutrition is a whole nother area. And so as my general rule, I like common sense. So you gotta eat healthy. So it's balancing your diet is the most important thing. In your car, if you've got a high performance sports car, you want to put good gas in there. You want to take care of your body. So what you put in matters. If you're on steroids and you're inactive, your risk for hypertension, diabetes, and cholesterol are high. So it's going to be imperative that you get on American Heart Healthy Diet. And there's so much literature out there. If you have questions about nutrition, take it back to your primary care. Getting a nutrition consult is very valuable. Any of your senior centers, any of your local hospitals have great classes for diabetes and the American Heart Healthy Diet. Insurance company will not pay for that nutritionist until you have diabetes, which in my mind is way too late. But you can get that at your community centers, educate yourself, educate your families, because you can't do your diet alone. So you have to do it as a family unit to make it work.
One follow-up to that. Magnesium, there's a lot of questions about, can myasthenics have magnesium? Should they take supplements? Should they completely avoid it, cut it all out? How's that work?
So magnesium is on our list of don't take ever. Well, if you're low in magnesium, you might need replacement. The best research studies on magnesium are the ones where we've done high dose supplementation. And where we do that is generally in pregnancy. And so women who have problems with preeclampsia or preterm labor, a lot of times we do very high dose magnesium. And that, in someone without myasthenia, can cause weakness. So it's really in the higher doses. Now, milk of magnesia, many of our medications we use with antacids have a balance between aluminum to bind you and magnesium to take care of the other side. And with the Mestinon, you don't need that other side. So you don't want to get too much. So it's working with your physician to supplement carefully. How's that for a judicial answer?
Can I add to that?
Yes.
I am hypersensitive to
Right.
magnesium. Even in medication,
Mhm.
I just went through all of the crisis taking isopril for my heart. It was
And there's magnesium. And everyone is very sensitive in a different way. So there are many of you may have cardiac disease or hypertension, and many of you are on a beta blocker. It's metoprolol, atenolol, many of those medicines. And those are medicines that we really don't like with myasthenia. So it's balancing risk and benefit. So when you're in a crisis, it's not the time to play with it. You have a very unique sensitivity to magnesium, and so that's almost on your allergy list. Good. So when you have a sensitivity, but you want to check anytime anything new is added, it's going to impact your MG. Look at it on the negative side, first, and then if you're okay.
Yes.
Thank you guys.
I want to thank all of you. It's been an honor to be here, and I just want to say that. I think what you all bring to the table is knowledge from a perspective that we sort of understand better than I, but you bring the right questions to us, and that's where research gets done, asking the right question. So thank you.
I just had a quick question. I had two actually. The first one was I had a friend that had really bad rheumatoid, and they got in touch with this doctor that put her on it. It was called LDN. It's a low dose naltrexone or something that actually they recommended for patients with MS. And I was curious with because it's not prescribed for MG or for MS. It's very hard to find a doctor that would do that. If what you would think about an MG patient trying
I think the MS, the literature with MS is still out. I mean, there's been a trial out at UCSF that did some work on it. It's still in the some believers and some not, and I certainly don't want to give any medical advice. I think you can look at the literature, take it to your own clinician. I think it's something that you really should get some advice on, because I think there's dosage issues and there's a variety of things, so it's not something you want to just sort of experiment with.
And then just one follow-up. For those of us that don't have MG but are the supporter of it, I mean, I know that there's not really much we can do but be supportive. So the one thing I was wondering is there ever going to be an MG walk in Atlanta? I know my sister did one in Florida. I know that's not necessarily for you guys, but it's, financially.
We're working on it.
Okay.
Actually, Atlanta is on the list for next year. I think it's going to be probably in the early spring. But we are on the list to have a walk here next year. don't quote me, Marchish. So, but we will definitely let you know. And that's, a good point. Okay, I just want to see how many people, just show of hands, kind of see where everybody is from. How many people are from, like, Atlanta and north? Okay, what about, like, in the middle Atlanta, or middle Georgia area? So, okay. And South Georgia, did we have anybody make it from South Georgia? Savannah, well, we have Savannah, yeah. Mm-hmm. Okay. South, it's middle, it's on the side.
You would have that.
We have two from Florida.
We have a couple, I know we have some from Texas, some from Florida. Okay, we have an Atlanta support group meeting, and the next meeting for that is first Monday in December. We meet on the first Monday of each month. And it's open to everybody, but we're also looking to how can we meet the needs of everybody else in other parts of the state, and how can we meet the needs of caregivers. So if anybody is interested in connecting, volunteering, please let me know. I can think of stuff for you to do. And if you have any ideas, things that you would like to see from the chapter, how can we serve you basically? What do you want? You can let us know.
Not a
That'd be
weekday
awesome.
night. Not weekday nights.
Yeah, look at different schedules. That's one reason why we hold the chapter meetings on the weekends.
I think we can answer that gentleman's question if we could all get the names of the doctors that we all use. So we could share the information from the doctors that these folks are using.
Right,
We can
connecting
answer that
people.
gentleman's question over there.
Mm-hmm.
Can I give a plug?
Yeah.
Can I give a plug for Daily Strength?
Yep.
Several of us are members of Daily Strength. It's an MG website where we have a support group. If you go to dailystrength.com, I believe is the website. There's several of us on that website. We talk on a daily basis, raise questions, offer support. We have a resource of all the MG documents that you may be interested in gathering on another site. But there are a lot of medical professionals, people with expertise that can help you. We just are there as a supportive group.
Daily Street.
Daily Strength.
Spell it,
Yes.
please.
That's like STRENGTH.
.org.
Yeah. Another thing, if you want, we have information, information on different treatments, different things from the foundation that the foundation has on the website, and then we can also contact the chapter, we can mail it to you. There's also a physician handbook that's got a ton of information in it that's very helpful, so that we can provide to you. So, one quick.
How long are you going to train before they do the walk, and how long would the walk be?
It's like a mile, I think.
It's a friendly walk.
It's just, yes.
Would you train, don't you have to do some training?
Not details.
No.
You can come out and sit at the desk.
Yes. Yeah.
Have more
Yeah,
people.
it's a fundraiser. And it's a good way to connect people with them. Is that it's a very good way to connect people. So, as Gary said, thank you all for coming. Thank you very much. Thank you guys very much.